When we talk about the water cycle, and particularly when you teach the water cycle, say in school, you think of that diagram and it has, the clouds dropping snow onto the mountains and then the water flowing off into the rivers and then it going into a lake maybe and then flowing into the ocean. And in many depictions, humans are absent. We don't see kind of that actually there's a giant dam, next to that lake, and that dam actually controls how much water is flowing into the ocean. So in this study, we used data from NASA's new ICESat-2 satellite, which launched in October of 2018, to try to better understand how surface water varies around the world. And so we intersect data from the satellite, which tells us the water level, so how much water is in a lake, essentially, with a global data set of where surface water bodies are and which ones are reservoirs and which ones are not. Try to better understand how natural water bodies and how reservoirs vary seasonally, and to be able to understand kind of the impact of human management on total seasonal variability in water storage. In my view, this study represents kind of a first quantification of the impact that humans have on the surface water storage kind of component of the water cycle. No one has ever been able to quantify this value before. And what we find is that reservoirs are significantly more variable, so the amount of water stored in them varies a lot more than natural water bodies. And in particular, they're responsible for 57% of the total seasonal water storage variability on Earth. So in other words, human management, so humans modulating the water levels of reservoirs, is responsible for the majority of surface water variability on Earth. Even though reservoirs actually only account for a very small percentage, only about 3.9% of the total water bodies that we observe. And the reason for this is that ICESat-2 is a laser altimeter, which means that it provides very high resolution, so really highly accurate observations of surface water level. This means that we can now observe the height of very small water bodies. As small as several hundred or 1,000 square meters. And so in doing this, now we can look at hundreds of thousands of water bodies instead of a couple hundred water bodies. And also we know that those observations of water level are quite accurate. In the future, as we have increasing population, we have growing development around the world and growing industrialization, we have growing demands on water through agriculture, and we also have climate change, which is changing the way that water is moving around the world. So when you have all of those factors, it's clear that there are going to be greater demands on water usage in the future. And so a study like this can tell us, okay, here is how water is currently being managed. Here is how humans are currently controlling the water cycle.